Jai Hind to all. Myself Yogendra Prajapati, Assistant Professor, Akgec Engineering College. Today I am going to teach very important topic, that is hash diagram. This topic is related to the discrete structure and theory of logic. Hash diagram. This topic is asked in university examination, full question, and in GATE examination 1 or 2 marks question. Now first we see what is the hash diagram. Before the study of the hash diagram, first we know what is the poset, because the graphical representation of the poset is known as the hash diagram. Poset is definition, that is very simple. Any relation is known as the poset if it is follow the 3 property. First one is the reflexive property, second one is the transitive property, and the third one is the antisymmetric property. If any relation follow these 3 property, then that relation is known as the partial order relation. And when we partial order relation are represent in graphical representation for the poset is known as the hash diagram. So this is the brief introduction about the hash diagram, and with the help of the different type of the relation, we follow these 3 type of the relation: reflexive, antisymmetric and transitive. Now for example, why we need to include the loop at every vertex? Loop of the every vertex is come from the reflection relation. Since its poset must have a loop there, it means when we draw the partial order relation, then loop are consist, and loop are consist with help of the reflection of the data. Now we see the minimum number of the steps by which we can design the hash diagram. Start with the digraph of the partial order relation. Remove the loops. It means when we draw the graphical representation of the partial order relation, then the first step we remove the loops, because by default in every point loop are automatically consist. Then there is no represent the loop, that is the reflection of the data. Then remove all the burst we represent, because and we remove the transitive relation. It means when we draw the graphical representation of the partial order relation, we remove the reflection relation and we remove the transitive relation. It means overall conclude the partial order relation, when we represent in the hash diagram, only one relation are shown, that is known as the antisymmetric relation. Arrange all the edges point to point. This is the method. This is the method by which we can draw the hash diagram. Remove all the arrowheads. Now we take the very simple example. Here is 1, 2, 3. These are the 3 different points by which we can draw the hash diagram. 1, 1 is the reflection of the this point. 3, 3 is the reflection of the this point, and 1, 1 is the reflection of the 1, 1. It means 2 relation to 3, 1 relation to 2, and 1 relation to 3. This is the hash diagram is given. Now the first step, we remove this loops. That loops is known as the reflexive relation. This one 1 relation to 3, 1 relation to 2 and 2 relation to 3. It means 1 relation to 2, that is one relation, and 2 relation to 3, that is another relation, and then 1 relation to 3, that is the known as the transitive relation. That is known as the transitive relation. So when we draw the any partial relation into the hash diagram, then partial order relation are removed. and loops, it means reflexive relation are removed. Only now this one are removed. Now 1 relation to 2, 2 relation to 3. Now this one relation is only represent the anti-symmetric relation. Now this one we arrange in the systematic order. It means the lower point are in lower way, upper point in upper way, and this is the upper. This one is known as the construction of this example 1, 2, 3. The relation between 1, 2, 3 is greater or equal. Now this is the method by which we can draw the hash diagram. 3 steps we follow to draw the any partial order relation into the hash diagram. First, we remove the reflection. Second, we remove the transitive. Third, we arrange the order. Now, this is our final hash diagram of this relation. For the better understanding, we take the more examples by which we understand how the hash diagram are drawn. We take the very simple example. This one, this is the directed graph ordered. Now, here is a C, A, B, T. What is the first step in directed graph? Yes, reflexive is relation are there. Is there antisymmetric relation or is there trans? 3 questions we can ask. Now, this is A related to C and A related to C, D and C related to B. It means A, B. Now, this one relation is known as the transitive relation. A relation to B and now D relation to C, and this one is this one, this one, this one and this one. Self loop is known as the reflexive relation. And if A relation to C is given, then C relation to A must not be given. If it is such kind of the graph are represent, then it is known as the antisymmetric relation. If it is A relation to C and C relation to D, then A relation to D are given, then that relation is known as the transitive relation. And the self loop is known as the reflexive relation. It means these 3 relations are present in this directed graph. So that if 3 relations are represented in directed graph, then it is known as the hash diagram. What is this step to minimize to correct the hash diagram? Now we take the another example. Problem is A set are given 1, 2, 3, 9, 18 and consider relation are divided, and for all A, B is 11. This is another question. This question is important in the view of the university examination. Many times this type of the question are asked. Now, A divided by B, and for every AB is some integer of k. Now, in directed graph, the relation has been the following appearance. Now, this type of the relation has been appear. I think 1, 2 divided by 1, it is correct. 3 divided by 1, it is also correct. 9 divided by 3, it is also correct. 18 divided by 2, 18 divided by 1, 18 divided by 3 and 18 divided by 9. Now, this relation and this relation and this relation, these 3 relation is known as the transitive relation, and this relation and this relation and this relation and this relation, loops are known as the reflexive relation. So, what is the step? We simply remove the transitivity and remove the reflection. All the directed graph arrow, Now 1 relation to 3, 3 relation to 18, this is the transitive relation, we are removed. Self loop are removed, that is the reflexive relation. 3 self loop are removed, and 1 relation to 2, 2 relation to 18, 1 relation to 18, that is the transitive relation. Now this one is the correct hash diagram of this one. Now this one is a transitive relation. This one, and this one, and this one is a reflexive relation. So when we draw any kind of the problem, we see only the 2 steps. The first step, remove the self loop. Self loop are represent the reflection relation, and remove the transitive relation. Now this one, for the better understanding, we take another example. Now see this one, just wait 1 minute, sir, ये डायग्राम दिख रहा है, ठीक है, ओके. Now check this one. In all points, self loop are given. It means when we draw the hash diagram, then remove the self loop and check the transitive relation. Which one is the transitive? I think the problem is here. This one, A, B, C, and the relation is the subset, and this one. Now phi is a subset of all set A and B, A and C. Now A is a subset of this one, B is a subset of this one, and AC is a subset of this one and this one. It means this is the relation R formed with the help of the subset. I think this point is also is here, because B is a subset of the phi. Okay, we see the transitive relation, identify in this hash diagram, and identify the self loop. We remove the transitive and self reflection, then we find the final conclusion of the hash diagram of this particular problem. This is our final solution. I remove all the transitive relation, all the reflexive relation. Now check this one. A is a subset of phi, again C is a subset of phi, again B is a subset of phi. Now this one. Now we check this point. AC is a subset of A. Now A is a subset of AB, and C and BC is a subset of B. Now AB is a subset of ABC, AC is a subset of ABC, and BC is a subset of this one. Now and AC is again subset of this one. Now we remove the transitive relation. This problem we remove the transitive relation and reflexive relation, then we find the final solution of this one. Check another diagram. I think here is a 1, 2, 3, 4 point, and weightage are given. What is the step we follow? Simply we remove this reflection and remove the transitivity. Now it means first we remove this one, this one, this one, this one. Now 4 relation to 6, 6 relation to 7, then this one is a transitive relation. It means by default 4 relation to 7, this one is a transitive. 6 relation to 7, 4 relation to 5, and 5 relation to 7, then this one is automatically removed. Now it means this relation is transitive relation, and I think this or this relation is transitive relation. Now 5, 4, 3, 2, 1 and 0. In this hash diagram, 0, 1, 2, 3, 4, 5 employs the omitted of the transitivity relation. We take the another example, this one. This is the 3, this is the 4, this is the 12, this is 24, another this 2 point. What is the problem? This one is our problem. 3, 4, 12, 24, 48, 72 and the relation is division. Then this one is the hash diagram has been formed. Let's check the example. Now 3, 4, 12 is divided by 3 and 4. These 3 points are drawn in the form of the hash diagram. This one. Now next is 24. 24 is divided by 12. If we can also say that 24 is also divided by the 3 and 24 is also divided by the 4. If we draw this one, then this is known as the transitive relation, and in a hash diagram no transitivity are involved. It means this one is by default, this one is by default are present here, but we remove the transitive relation. Now we check the 48. Now 48 is divided by the 24 and similarly 72 is divided by the this one divided by this one. Now this is the hash diagram of this problem, and this problem is also important because such kind of the problem asked in the university examination. We take another example for the better understanding. The input is very simple, 1, 2, 3, 6, 4, 8 and relation is division. Now the first point is 1. Now second point is 2. 2 is divided by 1. It means the relation is formed, 2 is divided by this one. It means these two values are related. Next point is 3, and I know that 3 is also divided by the 1. It means 1, 2, 3. These 3 point hash diagram has been drawn. Now next point is 4. You know very well that 4 are related to 1, 2, but 4 are not related to 3 because 4 is not divided by 3. Okay. Now it means this, if we connect this one, this is the transitive. You know very well that transitive relation by default are removed in the hash diagram. Now next one is a 6, and you know very well that 6 is divided by this point and this point. Now 6 is divided by the 3, it means this one, and 6 is divided by this one. This is the method, this is very simplest method by which we can draw the hash diagram of any kind of the problem which is asked in the university examination and also in the GATE examination. Now next point is 12. You know very well that 12 are related to this point and this point. Now 12 is divided by this 6, that's okay, and 12 is divided by the 4. It means this is the complete hash diagram of this problem. Now check this one. How many points are given? You can calculate 1, 2, 3, 4, 5, 6, 7, 8 and 9 points are given. I think what is this set? We can say that 1, 2, 4, 5, 1, 2, 4, 5, 10, 20, 25, 25, then 50 and then 100. I think relation are 100 divisible. This is the hash diagram are given. Now D100, D stand for the divisible, 100 means that is the upper point, and we check what are the, this type of the question is also asked in examination. D100, D34, K40 and relation is divisible. It means we start from here. 100 is divisible by 20, 100 is divisible by the 50. And we can also start from the here. And what is the our target? To reach the 100. This is another example for the better understanding. 2, 3, 4, 6, 12, 36 and 48 and relation is divisible. Start from the 2, then 3 and then 4. Then 4 is divisible by the 3 and 3 is not divisible by the 2, then this relation is not formed. Next point is, it means 2, 3, 4, this one is the hash diagram for this 3 point. Now next point is a 6, here is given, and 6 is divisible by the 3 and 6 is divisible by the again 2. It means this is the hash diagram of this 3, 4 point, 1, 2, 3, 4 point. Next point is that is better 12, and 12 is also related to this point, related to this point. I think it is the better understanding how we draw the hash diagram. Next point is a 36. You can consider that 36 is related to this point. Okay. Now this point, hash diagram of this point has been given, and similarly we draw the another point that is known as the 48, and 36 is not related to 48, but 48 related to this point. Okay. Now this is the hash diagram. For the better understanding, in next lecture I will meet you some important topic of the DSTL.